Let us now look at the next question of the IIT JEE 2017 advanced paper, and the question says, for how many values of P this circle given by the equation x square plus y square plus 2x plus 4y minus p equals 0 has exactly 3 common points with the coordinate axis. So let's represent this scenario by means of a diagram. So we have the coordinate axis, this is the vertical y-axis, and we also have a horizontal x-axis as usual, and this is the origin where the coordinate axis meet each other. Now note that we have to find the number of values of P for which this circle has exactly 3 common points with the coordinate axis. Now if you look at this equation, x square plus y square plus 2x plus 4y minus p is equal to 0, then looking at this equation you will realize that this is the equation of a circle first of all, and this circle will have its center at -1 and -2. So if we write down this equation in a slightly different manner, we can write it as x plus 1 the whole square plus y plus 2 the whole square is equal to sum r square, where r is the radius. We are not interested in the radius here, we are only interested in the center of this circle, which will be clearly at -1, -2. So if we locate the center on this diagram, we will find that its x coordinate is -1 and its y coordinate is -2, and so the center of the circle will lie somewhere here, and this is the point -1, -2, and we have to find for how many values of P this circle will have exactly 3 common points with the coordinate axis. Now the first thing to note is, suppose this circle is a tangent to the x-axis, the case in which the x-axis is a tangent to the circle. So in this first case we will say that x-axis is tangent to the circle. Now if you consider such a case and if you draw a circle that satisfies this case, that is x-axis is a tangent to the circle, then because the center of this circle is at -1, -2, then such a circle will look like this. So now we have a circle wherein this is the center of the circle and also the x-axis is a tangent to the circle. So this will be one possible circle because this meets the coordinate axis at 3 distinct points. This is the first point, this is the second, and this is the third point. So we now have a circle which meets the coordinate axis at 3 distinct points, and so at least this circle is there for which we will have a certain value of P for which this circle will cut the coordinate axis at 3 points. Now there could be yet another case, so we will assume another scenario, that is case 2, in which we will have a scenario in which P is equal to 0. So let us take the case in which P is equal to 0. Now suppose P is equal to 0, then the equation of the circle will be x square plus y square plus 2x plus 4y is equal to 0, because P is equal to 0 itself. And now because this is a circle, you will see that when P is equal to 0, this circle passes to the origin. And so if we now draw a circle satisfying this equation, it will still have the center as -1, -2, but now it will pass through the origin, and so we will have a circle that looks like this. Now note that if we extend these coordinate axes, you will realize that this circle that we are talking about meets the coordinate axis at 3 points again. So this is the first point, this is the second point, which is the origin, because the circle passes to the origin as P is equal to 0. Similarly, the circle will also have this point in common with the coordinate axis. So again we have a circle which is touching the coordinate axis at exactly 3 distinct points. So this is yet another case in which we can have a value of P wherein this condition is satisfied. Now only one more condition remains, and that is the third case. Now in the third case, we will assume that y-axis is tangent to the circle. Now let us see what happens when y-axis is tangent to the circle. Now because the y-axis is tangent to the circle, we will have a circle that touches the y-axis somewhere here. So I will draw a dashed circle here which touches the y-axis here, so that the y-axis is a tangent to this circle. But note that such a circle meets the coordinate axis only at one point, because here this circle never touches the x-axis, and so the only point of intersection of this circle with the coordinate axis gives us one single point, and so this third case is discarded. So we'll discard this third case, and so only in the first two cases can we have a value of p such that these conditions are satisfied. And so we will say that in case 1, whenever the x-axis is a tangent to the circle, and in case 2, whenever the circle passes through the origin, then in both these cases we can say that these conditions are satisfied. That is, this circle has exactly 3 common points with the coordinate axis. So in this first case, we saw that when the x-axis was a tangent, this satisfied the condition, and also when the circle passed through the origin, that also satisfies the condition. But this third circle does not satisfy the condition. So only in case of these two circles, we will have these conditions being satisfied. And note that because the center is fixed for a certain value of p, we will have similarly we will just have one circle representing that value of p. And so we can say that the total number of values of p for which this circle has exactly 3 common points with the coordinate axis is equal to 2. So we can now say answer is equal to 2. And the answer is, there are exactly 2 values of p for which this condition is satisfied. So the number of values that p can take is equal to 2.